This lesson is about solving absolute value inequalities in one variable. I'm going to look at a few cases here. I'm going to look at the case when you have the absolute value of a number is less than a positive number. Okay. I'm not going to include less than or equal to, but that really everything I'm doing for less than applies to equal to, except you have to include that number. The absolute value of x is greater than a positive number. And then we're going to look at two trivial cases. One of them is the absolute value is less than a negative number. You can get the answer right away there. You don't even have to solve. You just need to think about it. And the absolute value of x is greater than a negative number. OK. Remember that the absolute value is the distance from 0. So let's look at this case here. If the absolute value of the number x is less than a positive number, let's take 2 for example. If the absolute value is less than 2, that means the distance between x and 0 is less than 2 units. Distance is less than 2 units from 0. So if we look at the graph, and x is less than 2 units from 0, so we go to 2 here, and we're looking at any number here in this area between 0 and 2, and not including 2. So any number you pick here between 0 and 2 is less than 2 units from 0, so satisfies this inequality. But also, if you go to -2 and you choose a number between -2 and 0, you'll find the distance less than 2 units from 0 as well. So you see that we can take any number in between those two. And the way we translate it, so x has to be right here. Any number between -2 and 2, not including -2 and 2, would be a solution to this inequality. So notice that we can translate this to a compound inequality. The compound inequality would be, the translation would be, is x has to be less than 2. See, x has to be less than 2. And notice that, and because I'm looking at an intersection here between two sets. So if you go less than 2, you're going all the way there. If you go greater than -2, you're going all the way, and so the intersection would be right here. And that's why with less than, you translate to an and, because we're looking at an intersection. That's something you need to be careful about. Remember, less than and. So you translate it to x is less than 2, and x is greater than -2. And notice that the and means the intersection. We just got it right there. So that's the algebraic solution. The interval notation would be all numbers between -2 and 2. And we use parentheses because in this case, we don't have the equal sign down here. We just have the less than, so we're not including the endpoints. So remember, when you have an absolute value on one side is less than a positive number, you're going to translate this to two statements, which is a compound inequality with the and you take the first one is the same, get rid of the absolute value, so you have x is less than 2, same as it's in the original one. But notice in the second one, you're reversing the inequality symbol, and you're taking the opposite of that. So I'm going to take another example with the less than case that's more involved. So let's say that I have the absolute value of 3x minus 1 is less than 5. So this is an absolute value inequality with less than 5. So let's make it less than or equal to 5, so we can include that 5. Again, and it's less than, remember it's and. So we're going to translate this. We're thinking of a number, if I want to think about it. This number, 3x minus 1, is less than or equal to 5 units from 0. So I'm kind of looking at this 5 and negative 5. And if it's less than or equal to 5 units from 0, it could be 5 or less, could be negative 5 or greater. And I'm taking the intersection here. So my first step, if the absolute value is isolated on one side, my first step would be translate to a compound inequality with and. So I know less than, I'm going to use and. And then I take the 3x minus 1 less than, see it's less than or equal to 5. So my first statement would be exactly the same as the original without the absolute value. And the second statement, you take the 3x minus 1, switch the inequality symbol, and take the opposite of that number. And that's what this means right there. So now I have a compound inequality with and that I need to solve. So I solve each inequality, add 1 to both sides here. So I got 3x is less than or equal to 6. Divide both sides by 2. That gives me x is less than or equal to 3. And so I have that. And here I add 1 to both sides. So I got 3x is greater than or equal to negative 4. Divide by 3. So x is greater than or equal to negative 4/3. So that's the algebraic solution. But what about the graphical solution? So let me get rid of those for now and show you the graphical, how to graph it and write your solution in interval notation. So that's 0, less than or equal to 3. So that's 3, less than or equal to 3. I'm looking at this line. And then greater than or equal to negative 4/3. So let's say the negative 4/3 is right here, negative 1 1/3. And it's greater than or equal to, so we're going to shade it in. Greater than, we go to the right. And because and means intersection, we're going to take the intersection between them. So the solution will be negative 4/3 to 3, including both ends. So that would be the interval notation. Okay, one other thing about absolute values is that sometimes you may have an absolute value inequality that is not in the standard form. If you have it like this, that's in the standard form. And when it's isolated, when the absolute value is isolated, it's in the standard form. Sometimes you may have something like 2 times the absolute value of x minus 4 minus 3 is less than 5. And so when you look at this, you're going to identify it being an absolute value inequality. Then the first step that you need to do is write it in the standard form. So you need to isolate that absolute value because the absolute value is the distance from 0. And to solve them, we have to translate that to a distance statement. So my first step in isolating this would be get rid of that negative 3. So I would add positive 3 to both sides. So now I have 2 times the absolute value of x minus 4 is less than 8. And my second step to isolate this absolute value that's multiplied by 2 is to divide both sides by 2. And I'm not changing the inequality symbol because I'm dividing by a positive number. So the absolute value of x minus 4 is less than 4. And so now this is in the standard form. I'm ready to translate it. Remember, less than is with and. So x minus 4 is less than 4, and x minus 4 is greater than negative 4. And then I go from there to solve this inequality, graph it, and take the intersection of both of them, and that would be written in interval notation. So we're done with this case. When you have the absolute value is less than a positive number, remember we use and here. When you translate it to a compound inequality, you're going to use and. Now I'm going to look at the second case here when the absolute value is greater than a positive number. So if we take, let's say, the absolute value of x is greater than 3. How do I translate this to a distance statement? Well, this is saying that x is more than 3 units from 0. So if that's a 3, more than 3 units from 0 is going to be all the numbers to the right of 3. Also, more than 3 units from 0, it's going to be all the numbers to the left of negative 3. So any number to the right of 3 or to the left of negative 3 will satisfy this inequality. We're going to give you any number. So, for example, take 4. The absolute value of 4 is greater than 3, yes, because 4, the absolute value of 4 is greater than 3. And if you pick a number here, let's say negative 4, the absolute value of negative 4 is greater than 3, because the absolute value of negative 4 is 4, and 4 is greater than 3, so that's a true statement. But if you pick any number from here, let's say negative 2, that's not going to give you a true statement. So let's say x is negative 2. Absolute value of negative 2, is that greater than 3? Absolute value of negative 2 is 2. Is 2 greater than 3? And the answer is no. So there's no solution in between negative 3 and 3, including negative 3 and 3. Your solution is these two intervals, which I can write in interval notation, going always from small to large, negative infinity to negative 3. Both of the endpoints are excluded. I have to take the union because I need to take what's in A and B. Both of them satisfy the inequality. And this goes from 3 to infinity. So that would be the solution in interval notation. So remember that when you have a greater than, you have to use or this, because you're going to include both of them and you want to find the union of them. So let's take another example on this case, because the rest of the cases are trivial. That shouldn't take a long time. So let's say the absolute value of 2x plus 1 is greater than or equal to 7. So that's greater than or equal to a positive number. I would want to translate this to two statements, because if you look at the number line again, you're looking at 7 or negative 7, and this number is greater than or equal to 7, less than or equal to negative 7, but the number you're talking about is the 2x plus 1. It's not the x, it's the number inside the absolute values. So you translate the absolute value inequality with greater than to a compound inequality with or. So that means 2x plus 1 is greater than or equal to 7, or 2x plus 1 is less than, see to the left of negative 7, less than or equal to negative 7. So I translated the greater than, remember, something to remember, think greater than, great or. So you remember that when it's greater than, an absolute value is greater than, you're going to use or. And that's because your understanding of the distance, the meaning of the distance between that number and 0, and that's what the absolute value is about. So we need to solve both of them. I'm going to add negative 1 to both sides here. So 2x is greater than or equal to 6. Divide both sides by 2. X is greater than or equal to 3. Or, again, subtract 1 from both sides. So you get 2x is less than or equal to negative 8. And divide by 2. X is less than or equal to negative 4. And this is the algebraic solution. But to write the interval notation, I would really like to graph it. Greater than or equal to 3, so that's 3. We include 3, so we shade it in. Greater than, we go to the right. Less than or equal to negative 4, so that's negative 4. less than or equal, again, we shade it in, and for less than, we go to the left. So that's the solution. All what we need to do is to write it in interval notation. So follow me here. I'm going to write it here. So we're going from negative infinity to negative 4. And negative infinity, it's open, but negative 4 is closed. Union 3 to infinity, and the 3 is included, 3 to infinity, and open-ended at the infinity. Okay, so we're done with that. Remember, if you have more complicated inequality here, you need to isolate, write it in the standard form. Always isolate the absolute value and go from there. Do it the same way. And the two trivial cases that we're going to look at, where you can tell what the solution is right away without solving them, like those first two cases, is if you think, I have the absolute value, and it's less than a negative number. Let's look at an example. So if you have the absolute value of x is less than negative 3, for example, imagine that this side, the absolute value is a positive number or 0. So that's a positive number, could be 0. Is a positive number or 0 less than a negative number? No. And that means this statement is false. And if the statement is false, that means you have no solution, or the solution is the empty set. So that's the case when it's less than a negative number. You know that there's no solution right there, just because of this statement being false all the time. While if you look at the absolute value of x being greater than a negative number, an example would be the absolute value of x is greater than, I don't know, negative 5. So think this side is positive or 0. And is a positive number or 0 greater than a negative number? And that's always true. The statement is always true, which means that the solution is all real numbers. Doesn't matter what you plug in for x, it's going to always give you a positive or 0, which is always greater than a negative number. So it's all real numbers. Or in interval notation, all numbers between negative infinity and infinity. I think that's it. So when you study, you want to make sure you look at what case you're dealing with, write it in the standard form, translate it to an absolute value, a compound inequality with and if it's less than, compound inequality with or if it's greater than, and think about those two cases. And you don't have to solve them. You just need to know to understand what it means and give your solution being either in the empty set or real numbers, which sometimes you see it symbolized like that. That's it. See you next time.